All right, we are going to do a few different examples, and then you will be doing the rest of this as your assignment on top of the assignment you had a couple days to work on. Okay, first of all, this first one, and the first two questions, we have already done this exact same question a few times. The only difference between what we're doing today with this question and what we did before is when we were answering this before, the last question says like, find out how many hours it takes for the cells to be 800. We had to like type it in our calculator and look at the table and approximate. We're no longer approximating. We can actually solve for this answer. This is something I said at the beginning of this chapter. Eventually we'll be able to solve these. We couldn't do it like the first day of the chapter. So in a lab, 930 cells are present at the beginning of an experiment. During the first 10 hours, the number of cells decreased by 5% each hour. Write the exponential number of cells, y, present t hours after starting the experiment. So we're going to do the model first. The model, we have seen this formula. You either have 1 plus or you have 1 minus the r, and then you this particular. Will I be doing 1 plus or 1 minus? Why? Because the words decreased. Okay? So now the rate, we've got 5%. Why won't you? Does anybody know what happened? Okay, so since the percent is 5%, do we actually put in 5? No. What do we put in? 0.05. We take that 5 and we divide by 100, right? If you don't know how to do it, you take 5, you divide by 100, and we put in 0.05. Also, we should know the A value. The A value is the starting amount. What is that? 930. Okay, so our model is going to be, after I simplify this, y equals 930 times
0.5. Wait, no. Is 0.95.
Okay, well, like I said, I hadn't done it yet. So now, we are going to do the new stuff. This is what we did before. We're going to now do the new stuff. The new stuff says we're going to use logarithms. We're going to find the time to the nearest hundredth when the number of cells is 800. So I'm going to put in 800 into the y spot equals 930 multiplied by 0.95 to the t. We're going to solve for t. What should we do first? Somebody else does. Subtract what? Okay, so you're half right. I'm not going to subtract it because this is being multiplied. So we're going to divide 930. And you know what? There's no reason, because I'm eventually going to type this in my calculator, there's no reason you even need to reduce this right now. Let's not waste our time. Just leave it as 800 over 930, okay? After we do that, I now have, I have like 0.95 to the t equals 800 over 930. That's what I have. Make it a little bit bigger. I've got 0.95 to the t equals 800 over 930. How am I going to get rid of 0.95 to the t? 0.95 is a base. Log base 0.95 to both sides. And that you're going to use your calculator for. If you do not have the newer calculators that you can just do log base in, like you can just go math A, have the newer calculators, I will type it in the way I would need to type it in if I don't have the new calculator. I'm doing it right now. So I would have to type in log, and then first I'd have to do 800 over 930. And then I would close my parenthesis. And then I would divide that by log 0.95. That's how I would do it if I don't have the newer calculators, which I do, but I'm doing it the old way for you. Okay? Okay, so to the nearest hundredth, 2.94 hours. So, yeah. So if you have the newer calculator and you have this log base thing on it, I would just put my 0.95 there, and I would do 800 divided by 930. Same answer either way. Okay? Just depends which calculator you have, how you type it in.
Yeah, how did you get that?
Math. Up, there it is.
Yeah, it's
Up for yours?
Yeah, I
Oh,
don't have
okay.
C.
Oh, I guess I'm special. I must have a better calculator than you. Okay. All right, so I am not going to do number 2 because you'll be doing that one on your own. Now we look at number 3. I'm sorry, what? Yeah, hun. Yeah. Hold on. Respectful to others. If there's people asking questions and I'm talking and you're talking. It's one thing if you're whispering to somebody because it's not something everybody needs to hear and we don't want to be disruptive. But when you're just full volume talking when I'm talking, that's not respectful. Katie has a question. And it's not just you. Go ahead.
So when you went on your calculator, can you go like up for like to like show them the spaces?
Oh.
That's good. So like the first why I mean I get how you're trying to show it for like older computers.
That's the change of base formula. That's log 800 over 930 divided by log 0.95. Because I'm typing it in a different way. Like you can't put it in a little thing if you're doing it this way. For the top one, the base is 10. I know this is crazy and like time wasting, but I could also type in, instead of doing log, I could also type in ln for both of these, and it still does it. It's called change of base formula. You can do whatever base you want as long as you keep it the same base on the top and the bottom, and it will work.
So you can do.
But I don't want to spend a lot of time on that because you have a new calculator. You're going to do it this way. Like, it's a waste of time. All right? It's just those of us that have the older one need to know how to use our calculator. Okay? All right. We are not going to do number 2 together because you're doing that one on your own. I think I'm going to skip. No, okay. I'll go over this one. All right, I'm not going to do all these next few, but this one's a kind of easy one. That's why I was going to skip this one and do a harder one, but I'll just do this one. There's a couple of easy ones, but this one has the formula on the front, and this is where everybody messes up. Is just they don't type the formula in correctly, okay? Because there's like, if you look at this formula, this is an actual formula. It's called Newton's Law of Cooling. And then there's like T here, and over here there's a T sub 0, like lower 0, subscript 0. And then we've got a T subscript R, and then we've got a T subscript R. We have an E here, we've got a little r, and we've got a little t. Like there's just a lot of variables. Yes.
So the T represents log.
No. Okay. Well, let me tell you before you just start guessing. We can read. So this is an actual cooling, and this is, we'll use some common sense for a second. If I took out do with a hot potato. If I took out a hot potato from the oven, yep, took out a hot potato, there's another hot potato, okay? Take these hot potatoes out of the oven at the exact same time, and I sit them on my, and then I go do something and I get distracted and I forget about them. I come back later, which one's going to be colder? Yeah, because if there's more mass, it takes longer for it to cool. And there isn't a formula, I mean there's a formula, but there isn't a set time at which it takes all baked potatoes to cool, because all baked potatoes have different masses. That, oh my gosh. So this formula, you cannot on an item and say that's the cooling rate for every single item there ever was. Okay? So I'm just saying you have to do this formula over and over again when we do these problems. So here's the explanation of all these letters. We've got T subscript 0. This is the initial temperature. Subscript 0 means the temperature when time starts. No time has passed. Subscript 0. This is the first temperature, right when you take it out of the oven. Exactly. Yes, in this case that would be 375. Yes, which I'll fill it all in a moment. Now the temperature T, where it's just T by itself, nothing else, capital T, is after time has passed. So this T is temperature after time. T with little subs after time passed. Speaking of time, little t, lowercase t, is time. So in this case it says minutes. But lowercase t is time. And then there's one more t, which we have to go past the formula to see the next t. T subscript r. T sub r, that is the surrounding temperature. Possibly the room temperature, if you're inside of a room. This is the surrounding temperature. I'm going to call it room temperature. However, it could be outside, but then it's not a room if it's outside. Okay? So the R would be, not R, but T subscript R is room temperature. And then the last variable is R. Little r is the cooling rate of that particular thing. So again, a small potato and a big potato are going to have different cooling rates. So this is something we have to find every single time we do this problem. So we remove a baked potato from a 375 degree oven and place it on the counter in your 75 degree Fahrenheit kitchen. After 18 minutes, you measure the temperature of the potato to be 140 degrees. What will the temperature of the potato be after 29 minutes? Sounds easy? Take it out. Current temperature of the potato. What is that initial temperature of the potato?
375.
Okay. So we're going to start filling out this formula, and I'm going to put 375 in that T sub 0. Yep. Okay, and we place it on the counter in our 75 degree Fahrenheit kitchen. What is 75 degrees formula?
TR.
T sub R. Okay. The rest of the formula, it's just because it's like adding afterwards. E is E. E is E from your calculator. Okay, so I'm going to subtract 75 here. We're going to have E, which is E. It's going to be to the negative. I haven't plugged anything in there. And then we'll have that at the very end of our formula plus another 75. Okay? I haven't plugged everything in yet. That's why I left a space. After 18 minutes, what's that? That's time. Okay, so after 18 minutes, up at the top, I've got a negative sign, I've got an R, and then I have multiply by time. So multiply by 18 up there in the next. After 18 minutes, the potato is now 140 degrees. So this 140 degrees is is temperature after time. Temperature after time. That's the big T without anything. So I know that over here is, what would I say, 140. So what is missing from this formula?
Cooling rate.
The rate. Because we don't know the cooling rate of that particular potato. All I know is for 18 minutes, this is how much it went down. So what we're going to do is we're going to solve for the cooling rate. And then I'm going to go back and answer the second part of the question. So I didn't even read that second part again. Because that. Let's see. You guys want to definitely use your calculator. So I'm right now, all I'm doing is I just simplified 375 minus 75. Next thing I'm going to do is subtract 75 from both sides. So 140, take away 75. See, I'm using my calculator to make this go faster. 65 equals 300, e to the negative 18r. Trying to get r by itself. We're going to divide by 300 next. Divide by 300. So I've got e to the negative 18r is equal to, I'm just leaving 65 over 300, okay? Because the next thing I need to do is get rid of, then how do I get rid of e?
No, use logarithm.
We use ln. ln is how you get rid of e, but you got to do it to both sides. Negative 18r equals whatever the answer for ln of 65 divided with 300. I don't even need to know the answer yet. What am I going to do next? Divide by negative 18. Okay. I hear wait, but then I don't know what I'm waiting for because that person doesn't finish their sentences.
It's not me.
No, I think it's Katie, but I'm not sure. Okay. So you guys who don't need me to wait, type that in your calculator. Okay? Gotta make sure we know how to type it in the calculator correctly. Depends on which calculator you have. I'll type it in like I don't have anything fancy about mine, even though I would type it in different because I got to. So I just found the cooling rate. I cannot remember if I have taught you this next thing yet or not this year, but I'm going to teach something to you either for the first time or the second time. I don't remember if I taught you already. What I'm going to do with this number so I can save it and deal with it later, okay? Because I'm going to need it again. Approximately over here. It's around 0.0849666-ish, okay. But what I'm going to do is I'm going to leave this on my calculator so I don't have to retype it, so I don't have to go find it later. I'm just going to save it in my calculator. No, I'm just joking. I'm about to tell you. To save it, there's a button down here, and it's STO. It means store. So you hit that button, and it says, would you like to store this answer? Yeah. What would you like? We're going to store it as R. That makes sense, right? 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 Okay. So to store it as R, I'm going to do alpha, and I'm going to go find R, which is time symbol. See how I'm storing it as R? And I hit enter, and it's stored as R. This is an ASAP, Jessica. This is an ASAP. What? Didn't do it.
That's cold, bud.
That on your calculator first. Don't store it.
Oh.
Good to know you're long. All right. Now, I have this stored. What I have found is I know the cooling rate of one potato. So what we're going to do now is what will the temperature of the potato be after 29 minutes? This is a teeny tiny bit confusing. This means 29 minutes, like 18 have passed, it's like 11 more minutes longer. Okay, it's not 29 minutes from the first 18 minutes. It means total, okay? So what will the temperature be of the potato after 29 minutes? So what I'm going to do is my formula. And I'm going to have to move some stuff around. I'm going to restart my formula. This is a restart of formula. I'm going to put it under the answer space. So what will the temperature be after that 29 minutes has passed? That means I don't know the capital T, because that's temperature after time has passed. So I don't know that T anymore. But I still know that it came out at 375. I still know my temperature in the room is 75. I still know E because it's always there. I still have the negative sign because that's part of the formula. R has not changed. It's the same potato. But I don't really want to write that whole decimal down, so I'm just going to put R there. But, like, I know that this is the rate. Is that okay? My time has changed. What is my time now? Nope. A total, 29. And then we have a plus sign after that, which is the room temperature, 75. So all I had to do was keep my same rate I found, but change my time to 29, put everything else the same. There is no variable over here. I can type that in. So when I type it in, you don't even have to simplify anything. 375 minus 75, parenthesis, e to the negative r. So I'm going to do alpha times symbol. There's my r. And then I'm going to hit times by 29, the minutes, over plus 75. So I typed it all in. I already saved r, so it's in. And I hit enter. And I get approximately 100.53 degrees. About 100.53 degrees.
I got it a whole different.
Okay, first of all, if you did not have R saved,
I did have it.
okay, first of all, if you did not have R saved, you will not get the same answer as me. The second thing you need to do is make sure you typed your formula in correctly. Is there a negative sign up there? What? Uh-huh. Oh, so let me do it if I have an old calculator, okay? So if I have an old calculator, 375 minus 75, and then you still have the E. It just doesn't, wait, yeah, it puts this in, right?
Yeah.
Okay, so then you would do parenthesis, negative alpha R times by 29 close parenthesis. You just need parentheses around your up. And then, no, you should be able to still do plus 75.
Yeah, I just put it in.
Yeah. Okay.
I'll put mine in parentheses. Well, I didn't put the R in.
So you do negative R.
Okay, there you go.
Okay. We're going to do one more. And It's number 5. It's number 5. Oh, I'm doing Celsius. It's not capital E. It's the look up here. Okay, we're doing number 5. This is the last example we're doing together, and then I can answer questions about the other assignment, or if you have no questions because you haven't done it, then at 11:13 p.m., a coroner arrives at the home of a person who was found dead, measures the temperatures of the body, measures the temperature of the room, and it says the body is 84 degrees and the room is 67 degrees. Where it says respectfully, that means the order of which they're saying, that's the order of which these temperatures are. So they found the dead body, 80 degrees, 67 degrees. After talking with the family and gathering other evidence for 40 minutes, the coroner, I can say corona. It's in my head. Maybe that's how this person. The coroner remeasures the body temperature to be 78 degrees. Estimate the time of death. Okay. Now, in order to do this, we need to assume that the normal living body temperature is 98. Questions trying to make it easier on you and make it 99. So we're assuming that most people have 99 degrees for their normal temperature. What do we not know about this person that's going to be different for every single dead body ever?
How he died.
No.
We know that, like,
Well, that's what we're trying to find. We don't know their mass, and their mass is going to affect their cooling rate. What we have to do, and what the coroner does, is they measure the body immediately. They have a specific time where they come measure the body again. That way they can measure the body at 2 different temperatures and find the rate of that particular body. Because all bodies are going to cool at different rates. So we need to first use this information to find the cooling rate of this body, or this hot potato. This body, though. Okay. Okay. So, currently, at time 0, 84 degrees. So this is our T sub 0. I know the formula, so I don't have it in front of me right now. You guys have it on the previous page. I probably should write it. And then we're going to subtract off the room temperature. What is the room temperature? 67 degrees. We're going to multiply that by E to the negative. Now, we do not know the cooling rate of this person, so R. But we do know the coroner waits 40 minutes to reevaluate that again. And we do plus, again, the room temperature 67. After this time has passed, what is the body temperature? 78. So what the coroner is doing first is seeing from 84 degrees to get to 78 degrees. Okay? So we're going to solve it. 78 equals 84 minus 17? Okay, don't tell me the wrong answer because I believed you. To the E40R, we're going to subtract 67 from both sides. So R, and then what am I going to do? Divide by 17, so I'm going to have 11 equals e to the negative 40r. So that was just getting rid of numbers. Our next thing we need to get rid of is what? E. So how do I cancel out E?
LN.
ln. Do that to both sides. If I do that to both sides, I now have ln 11/17
Is that times 40?
is what times 40? Yeah. ln 11/17 equals negative 40r. divide by negative 40. And at this point, it just became a calculator for me. I'm going to type it in the way somebody who has the calculators would type it in, but you guys, you do it how you want. If you want to use the fraction button. It's alpha y equals, or some of you can do alpha x, but not everybody can. So I found rate. This is my R. Y does what?
Okay, it keeps saying I have an error, but
Then you probably do. I will look. Give me a moment. So I'm going to store that as alpha times symbol R. Oh, you got it. Just got to store it so I can use it. And I paused for those of you who are desperately trying to catch up. I know that's not a phone in your hand right now. Nope, I know it is a phone in your hand right now. Devin, phone. Wrong.
It's charging.
Oh, but it's in your hand. Oh, do you have that new that I just made up right now? Okay, next. We did not follow the time. The body died. What we just found was the cooling rate. So we know the cooling rate of this particular body. Now we need to go back in time. And we got to figure out at what time this person was 99 degrees Fahrenheit. Oh, did I type something in wrong?
You wrote it down.
Oh, what did I write down wrong? Oh, that's what you're saying. I'm sorry. I was confused. I forgot a 0.
So it'll be 0.9.
Well, I'm not going to round that. I want the accurate time of when this person died. So if there was a murder, I can place it, with the time. Exactly. Not why they died. Okay. So now we need to find out at what time this person died. So now what I'm going to do is try to solve for the little t. We're going to solve for the little t. We do know the new temperature when the coroner walked in the room. I know the temperature was 84. That is now after time has passed. That becomes after time. Original temperature of the body when it died was 99. So we're kind of like going back in time. 99, take away the room temperature, 67. Multiply by e to the negative. We know r, I'm just not writing it here. But we don't know time. We don't know t anymore. And then you add on the room temperature. So what I did different from the first one to the second one is I said now 84 is the after time and 99 is the original time. Here, 78 was the after 40 minutes, where 84 was the original. Okay, so we're going to solve for t this time. 99. So we got 84 equals 32 e plus 7, 67. 17 equals 32 e to the negative RT. I'm going to divide by 32. That's 17 over 32 equals e to the negative RT. In both sides. So now I've got ln of 1730 seconds equals negative R. do to both sides.
Divided by negative R.
Right, but we know what R is. I just don't want to write it down because it's ugly. And I save. So this is what I type in my calculator.
Hold on, keep that up, keep that up.
Well, yeah, so divide by a negative R. It's approximately 58 minutes. We're not going to go to the second, okay? 58 minutes. I don't know which direction you want me to scoot the paper. So is that the answer? 58 minutes. I didn't put it on the answer blank. Ooh.
Ooh.
You find, because you got there at 11:13, so you subtract 58.
Yep, he got there at 11:13. We got to go 58 minutes before 11:13. And you really can do this however you feel most comfortable. Maybe you think about 58 being close to an hour. So if we subtracted an hour, it'd be 10:13, but we're not subtracting an hour, we're subtracting 58 minutes. 15, that'd be one way of doing it. Or maybe you subtract like 13 and subtract 13 minutes away from that. And then what's left, it should be. So now we can, make sure everybody gets their alibis and find out where you were at 10:15.
If we did .12, would that be kind of that seconds?
Well, it wouldn't be 0.12 seconds. It would be 0.12 of a minute